So I come with good news, and the good news is that the problems that we're trying to solve today, most of them have already been solved by nature. Life has been on Earth for about 3.8 billion years. So that's 3.8 billion years of R&D for how to innovate, how to be productive, how to be resilient, and how to be sustainable, which are really the goals that we all have today with all of our businesses. So we can look at nature as being a catalog of solutions that we can use and take from in order to create the designs for today and for the future. And this is what biomimicry does. As Beth mentioned, it's using nature as a source of inspiration for our designs, for sustainability, and even for social innovation. So, for example, if we want to create a robotic arm that's both very strong and also flexible, who better to learn from than an elephant? And the company Festo in Germany, that's exactly what they did. They needed a robotic arm that was very strong and flexible, and so they learned from the master, which is the elephant, and they replicated the trunk using relevant materials. And we can also use biomimicry to think on the system scale. If we want to create cities that are resilient and sustainable, or even beyond that, regenerative, who better to be our mentors than natural ecosystems? And we can think of our businesses and industries as systems as well, which is what they are. So we can learn from the principles that make ecosystems innovative, productive, resilient, and sustainable. And we can apply those same principles and strategies to how we run our businesses and form our industries. Oh, and an important note is that nature doesn't have to choose between being profitable and being sustainable. It's both. And so if nature can be both, we can be also. And for the theme of this summit, to make our additive manufacturing more effective and more sustainable, who better to learn from than the master, the original additive manufacturer, which is nature. We've been doing additive manufacturing for about almost 45 years now, but nature has been doing additive manufacturing for about 3.8 billion years, because all of life is built from the bottom up. Everything is additively manufactured in nature. And I was really excited when I went onto the website for the first time for the AM Summit, and I thought, wow, this is so cool. They're already inspired by nature, because the design that we're seeing everywhere is a symbol of one of nature's really beautiful additive manufacturers, the radiolarian. So radiolaria are a type of microscopic organisms that live in the ocean, and they actually come in many different forms, and they're quite beautiful, really exquisite shells that are additively manufactured. And they do these shells sustainably by using very local ingredients, literally what they're swimming in, and they're able to build these structures at ambient temperatures and pressures, so they're minimizing the use of energy. So when I thought about how can we use biomimicry for additive manufacturing, I see that there are 4 key areas that we can really benefit from by using biomimicry. The first is what we're putting into our printers, the materials, and I really want to echo what Beth said in her video, that this is an area that we need to focus on if we're going to have a sustainable future. We can also use biomimicry to design our products. We can use biomimicry to improve the process itself of additive manufacturing. And we can use biomimicry to design industrial systems, which I'll define that a bit later in the presentation. And for this talk, I'm going to focus on 1, 2, and 4. There's still a lot of work to be done for the third part, using biomimicry for additive manufacturing processes. So I'm going to give some examples of materials design, product design, and industrial systems. So starting with material design, I came across a report that had some terrifying bit of information in it. And that is that if we continue on the track that we're on today, the way we make plastic, use plastic, and dispose of it, by 2050, studies predict that we're going to have more plastic in the ocean by weight than fish. This is terrifying, and we can't let this happen. And the good news is that we don't have to let it happen. We don't have to get to this, because there are already solutions in nature that we can be inspired by. And here's just one example. In the oceans, there are microorganisms that literally feed off of carbon dioxide, and they use that CO2 to form polyhydroxybutyrate, PHB. It's a polymer that they use for energy. And a company was inspired by this. And over the course of 10 years, they figured out how to replicate or emulate what happens in the ocean with these microorganisms on land. So they are synthesizing PHB on land by emulating these microorganisms, and they've created a product that they call air carbon. So this air carbon is a biomaterial. It's approved in the US to come in contact with food. It's home compostable. It's actually carbon negative, so it's not just net neutral. It's carbon negative because it's pulling carbon dioxide out of the environment and storing it within the material. And it's dishwasher safe, and it has high strength over a range of temperatures. And the good news is that it's also meltable. So people are using this in 3D printing, and studies are underway right now to improve this material as a feedstock for 3D printing in multiple uses. Oh, and I didn't create a slide for this, but I wanted to mention another really interesting company who is working with concrete. So they're using the same type of concept of pulling CO2 out of the air by replicating the way corals build their coral reefs, and also the way the earth forms rocks, to create a concrete agglomerate. And for anyone out there who's interested in concrete and using concrete aggregate for 3D printing, I highly suggest you look at the website blueplanetsystems.com, blueplanetsystems.com. What they're doing is fantastic. If you use this material, they claim that a building that's made out of this material will actually be carbon negative, not just carbon neutral. So I want to give a few examples of products, and one of them is this fantastic Pinarello bike that we have here. What an honor to be in the same space as the world's fastest bike. And of course, there are many different factors that went into making this bike the world's fastest bike. And one of those factors is nature-inspired. So you can see the vertical tube, the green, white, and red tube. And on the front side of that tube are bumps. If you look closely, you'll be able to see those bumps. And those bumps were inspired by the front side of the flipper of the humpback whale. You can see those bumps. Those are called tubercles. And these whales are massive, of course, but they're able to turn very quickly, and they're able to make very tight turns. And so scientists were curious about this. How can they do that? And they found out that those bumps on the flippers give the whale more lift, and it reduces drag. So we can take that same concept and apply it to a design, which is what happened in the case of this bike. And the drag on the bike was significantly reduced, so it goes faster. Another interesting future that we have to look forward to is that within 20 years, it's expected that there's going to be double the number of planes that are flying in the air. So it's imperative that we make our planes more sustainable. And one of the ways we can do this is by making them lighter. And so a really fantastic solution came from the fusion of biomimicry, artificial intelligence, and additive manufacturing. And as David touched on, this was done by Airbus, Autodesk, and AP Works. And they needed to create a lighter weight partition between the cabin and the galley, the area where the hostesses hang out. And they were inspired by the slime mold. Slime mold has no brain, it doesn't have eyes, it can't walk, and yet it's very good. It's an expert at finding the fastest pathway or the most efficient pathway between two different points or multiple different points. So they're really good at optimizing networks. And this has inspired scientists to write algorithms that emulate the way these slime molds optimize networks. Another source of inspiration for this project are bones. As bones grow, material is placed only where material needs to be to resist external forces. So an algorithm was written that emulates the way bones grow and efficiently places material where it needs to be and doesn't put it where it doesn't need to be. So bones end up being very lightweight, or they find the sweet spot. They're able to find the sweet spot between being lightweight and yet being very resilient to all of the external forces, having the right mechanical properties for the context that they're in. So taking those two algorithms, they put that into this AI system, generative design, and they were able to put in the constraints of the problem, the temperature, dimensions, different properties that needed to be achieved, and the goals. And they were able to generate a portfolio of various solution possibilities that were arrived at very quickly. It would have taken designers much longer to do this on their own, and the best part is that they had that nature's intelligence behind it to help design the system. So the end result is this beautiful partition that uses 95% less raw materials, is 45% lighter, uses 3,200 kilograms less fuel per partition per year, and at the moment it's the world's largest 3D printed airplane component. And of course they're looking at evolving from here. What's the next part that we can replace using this methodology? So this is a great example of different technologies or different approaches to solving problems coming together. And this example that I want to present next is a personal one that I experienced at my work at Johnson & Johnson. It has nothing to do with 3D printing, but it's just an example of the way that nature can help us solve problems in a different way. So I was given the challenge of protecting the skin from irritating liquids. And for this, I thought about many different functions that I could potentially achieve by asking, for example, the question, how does nature repel fluids? Because if we can use the function of repelling fluids to protect the skin from irritating liquids. And so by asking this question, how does nature repel fluids, I was able to see many different ways of solving this problem. And one example was inspired by the lotus leaf. The lotus leaf is an expert at superhydrophobicity. And it's because of its surface structure that makes it superhydrophobic. There's microscale bumps upon which are nanoscale bumps. And it's this combination that makes them superhydrophobic. And you can see in this video that water is unable to spread across the surface of the lotus leaf. It just beads up and it rolls right off. And there was a company that emulated this using non-toxic materials to protect fabric from red wine or other liquids that could stain the fabric. So this is inspired by the lotus leaf. And I had the same idea to use this for, as a method to protect the skin from an irritating fluid. And so on the left, you'll see a typical product, and on the right was the biomimetic prototype. And you can really see the difference in how water is able to adhere to the surface of the skin. With the biomimetic concept, there's very little contact that's made. And this was a completely different mechanism that was used to solve the problem than what the company or what's on the market has approached. So biomimicry within J&J, applying it across a wide variety of different areas, we were able to come up with more solutions faster, and they were much more unique than what was on the market already, and oftentimes more sustainable as well. So with this emulation of nature comes learning about nature and feeling more connected to nature, which also, it just feels good. It gave us much more work satisfaction to be learning from nature. And finally, thinking about nature on more of a system scale, ecosystems are really good at minimizing energy consumption, and there's no waste in nature. And a lot of these wonderful properties that ecosystems have are because of the collaborations that exist between different species. And here in Denmark, about 50 years ago, in Kalundborg, they had the idea, hey, can we set up an eco-industrial park that emulates the way ecosystems function. And that's exactly what they've done. And today, this is an excellent role model for everywhere else in the world for setting up their industry ecosystems. So the waste of one company becomes the resource of another. There's no such thing as waste heat. It's all being reused with great benefits. So there are much less CO2 that's being released into the air. Tons of materials are being saved or recycled, and groundwater is being preserved. But we want to go beyond just reducing, doing less harm. What we really need to do and start thinking about right now, and there are people who are working on this right now, is we need to do good. We need to think about ecosystem services. As you can see in this image, the forest provides all kinds of services. It's using benign chemistry to generate oxygen, to sequester carbon, to build soil, to filter water, etc. And the problem is that when we cut these forests down and we put on top of them our cities or manufacturing plants, etc., we're not replacing the ecosystem services that the land provided before that was there. So this is why we're in the mess that we're in today. And the true definition of sustainability is giving back. It's being generous. It's how can we create cities, manufacturing plants, industries that are actually giving back to the planet, generating oxygen, sequestering carbon, supporting biodiversity, etc. And I believe we can get to this where our factories, our cities function like forests through biomimicry, additive manufacturing, artificial intelligence, and many of the other tools that we have on hand today. But if we're just using artificial intelligence or even just human cleverness to design solutions, I'm afraid we're going to miss the sustainability mark. We need nature's input to design systems that are truly resilient and durable over the long haul. And that's where biomimicry comes in. So I believe biomimicry is an essential element for design and for sustainability. And so I'm going to leave you with this challenge for everyone in this room. The next time you're faced with a challenge and you need to solve the problem, instead of jumping right into designing the solution, step back for a second and ask this question: how has nature already solved this problem? And if you try to answer this question, I can guarantee you're going to start to think of solutions in many different ways. And the way you design is going to transform radically for the better. This has been my own personal experience, and everyone that I know who works in biomimicry has had this experience as well. So I encourage you to ask nature and invite nature to the design table the next time you try to solve a challenge. Thank you.